Good morning, NDC Oslo. Oh, come on. It's the first session of the day, but we can do better than that. Good morning! Hey! Fantastic. Well, thanks for coming, and I'm really excited to be here to talk to you about cloning your voice with Azure Custom Neural Voice. So this is a bit of fun, this topic. It's not necessarily supposed to be taken seriously, but I hope you go away with some knowledge and can maybe try what I've done yourself. So a little bit about me. Hi, I'm Callum. You can find me on Twitter at Callum Whyte. I'm a Microsoft MVP for a few years, and Umbraco MVP. Umbraco is an open source .NET CMS. If you're ever looking for one, it's fantastic. Come chat to me afterwards if you're interested. I work with that fairly regularly. A .NET developer by trade, but now I'm running my own agency in the UK. We have a small team of .NET and Azure experts. I speak at lots of events. I get to travel all over the world, very fortunate. Also organise a handful of my own events, conferences, meetups, user groups, etc. I have a passion for food. I love Italian cuisine and the culture. Nowadays, as I'm not really a developer day to day, I'm doing more managerial stuff. I spend a lot of my evenings experimenting with technologies. I love to travel. I love to visit new countries, experience new cultures. Why am I telling you all of this? You don't need to know everything about me, but where the hell do I get the time? Because I'm doing so many things. Well, it's been speculated before that I have an army of clones. And I'm here today to tell you that it's true. I have 3 clones, or 2 clones, and myself. There is Callum Whyte, who seems to be related to Dylan Beattie. He's got the same hat and glasses. There is myself, Callum B. Whyte, and there is Callum C. Whyte, or Callum C. Whyte. He's a rapper. He's got gold teeth, a chain, thug life hat. Basically allows me to be somewhat cool in another life. Of course here, I'm joking, but we all wish we could have a clone, don't we? Even just to do those menial tasks like doing the dishes or perhaps attending meetings on your behalf. So that's sort of the premise of what I'd like to explore a bit today. Can we really clone ourselves? Unfortunately, I don't think the technology's there quite yet. We can't step into a room with this glass chamber, lock ourselves in, press a button, and suddenly have an identical version of ourselves. But we can go some ways to replicating this sort of thing with modern technologies. This talk was largely inspired by a video I saw during COVID. I don't know if anyone recognizes this. This man is called Jesse Orrell. He's a video producer for CNET. Now, with everything going online during COVID and having to do like daily stand-ups and meetings, he felt this was quite laborious, and it would be nice if he could augment his presence in these meetings without necessarily participating. He can sit back in his pajamas, drinking a cup of tea, and not really have to participate. So what he did was he set about recording all of the common responses that you might have in any boring meeting you're in. Nodding, I agree, that sounds good. You don't really need to say anything. It gets slightly more complex when you need to give maybe a slightly more serious update or a bigger project update, but he pre-recorded those as well. And he sat there with a video mixer and basically just pressed buttons to play canned responses that he had to the meeting. And this got me thinking, oh, could we do something like that, but with technology? Could we make a more realistic presence so that he doesn't have to necessarily be sitting there and pressing buttons? The way he did this, as I said, he went and recorded lots and lots of sections of content and variations of that content. So in addition to just the hi, hello, he would have different outfits on, all kinds of things, so he could play things on different days. He managed to go a whole week without being in a meeting or without physically being on camera in a meeting. That's quite cool. So can we clone ourselves like Jesse? I think we can. Now with the advent and the popularity, wide accessibility of something like OpenAI, Azure Cognitive Services, these tools to do these sorts of things are at our fingertips. We can train models to clone our voices, as we're going to see a bit later today. We can do image generation with things like DALL-E, and now all of the kind of chat GPT era things have also come about. So we've got Bing chat and everything integrated into all these products. It sparked a bit of a war. It is clearly the era of AI and ML. To the point where, in doing some research for this talk, I found some quite interesting things. Just last week, CNN did an episode where they cloned one of their producers' voices and were able to call up his bank on his behalf and get through all kinds of authorization because they had a copy of his voice. There is a very, very smart OnlyFans model who has created a virtual girlfriend that for $5 a minute you can talk to. She's making loads of money. She's cloned herself, and she's selling that online. Even Apple, in their latest iOS 17 that's about to come out in a couple of weeks, have announced a whole heap of accessibility features, really important things to help improve people's lives. In this case, being able to create a copy of your voice in your phone, so that if you were ever to be in an accident and couldn't talk, or maybe even for some more day-to-day purposes like responding to calls, you can do that, and you can train this all now locally on the device on your iPhone. That's really impressive. It's definitely the era of AI. So we're going to have a little look today about how we could do this ourselves. Can I clone my voice? That's the big question. Yes, I think we can. And before we dive into the how, we need to talk about the sort of history. I need to give you a bit of a science lesson. I'm sorry. I know that it's a Thursday morning and it's early, but please stick with me. So this is the human noise maker. This is our voice box. And I'm going to explain sort of how we're actually, as people, making noise. This is the same process that animals use to make noise in like monkeys and dogs and similar. But it's very important to understand just how we make noise, because we need to somehow replicate that with technology. So the way this works is we use our diaphragm to force air up through our voice box, through our trachea, that's our windpipe, which then goes through to a thing called our larynx, and the larynx is effectively a valve. Think of it as a pair of lips inside your windpipe that opens, closes, and moves into different shapes. And its purpose there is to create different vibrations. Voice is all about vibration. So the different sounds we make, it's all just a different noise. A different vibration with different energy, and therefore we produce different things. Of course, our tongue, our teeth, other parts of our mouth as well help change how that sound is shaped on the way out. But for all purposes, that larynx is the most important bit. So we've got to also learn a few key terms about acoustics, because not only is this a biological thing, this is also a physical thing. Sonority is a word that you're not going to need to know too much about, but I thought it was important to explain for context. Sonority is about the energy that goes into making a sound. So how much of that vibration is going to come out of your voice box. And it really determines sort of the difference between two words, for example. Vowels, hopefully, we're all aware of what a vowel is, but for those that don't know, it's the A, E, I, O, U in English language, and it's a sort of longer, more open sound. And that's a crucial differentiator. So in this case, the larynx is going to stay open and wider, and it's going to be as I say, a more open sound, like a ooh, an ah. Hopefully you'll be saying those things after my talk when we're finished. There's also consonants. Consonants are these shorter, sharper sounds that make up words, so the t or a k or a d sound. Those, in that case, my larynx isn't doing that much. Those are largely in the mouth and largely tongue and the teeth. But again, a key part of any word. Syllables. These are the bits that are basically stringing all of our vowels and consonants together. It's chunks of letters to make up a word. And finally, a phoneme. So a phoneme is the characteristic of a word that makes it unique. So this is your way of detecting that a ball is not call, because B in that word is the phoneme. It's the unique value. K in call is your unique value. If you had a multi-syllable word, then you may have multiple phonemes in a word. But for all purposes, these are the key characteristics of a word and of speech. So, I'm a big Apple fan. And if anyone's seen the movie Jobs with Michael Fassbender in it, you may be familiar with this phrase, it has to say hello. Back in the 1980s, when Apple introduced Macintosh, this was their kind of big splash into making a big consumer PC. And Steve Jobs had this obsession with it needs to be able to say hello, it needs to be human or humanoid. And so yeah, there's a great clip from the launch event where we see a computer in the 1980s talking. I'll play it for you very quickly.
Hello, I am Macintosh. It sure is great to get out of that bag.
It has jokes as well. So yeah, they in the 1980s had a very, very robotic sounding, but it's a computer talking, and it's not a pre-recorded sentence. There, it's actually the machine deciding which sounds it needs to make so that it sounds a bit like the English language, just very robotic. So that's sort of where we're going, and hopefully we can make a more natural sounding voice today. I said this would be a bit of a history lesson. I'm sorry, stick with me, please. Does anyone in the audience know what this is? You can shout out if you do. No. Fantastic. So you're going to learn something. So, yeah, this is a vocoder, or voice encoder. And it was developed in the 1930s by Homer Dudley at Bell Labs, which went on to be AT&T in the US. This is effectively a machine, a very scary-looking machine, that is turning electrical signals into, voice, the energy used from my voice, into electrical signals, so that those could be transmitted. This was used during the World War II, to scramble communications between the UK and the US, for example, as a way of encoding your voice. And this is really the very, very start of speech synthesis. Here, you can use these scary-looking keys to sort of manipulate the voice on, manipulate the signal of someone's voice on its way out of the machine. So you can start to change sort of how it can say things or how it can sound. Again, you're going to end up with a very, very scary, robotic-sounding voice, but it's the core principles. What this does, takes that electric signal and it puts it through some filters. Filters are there to strip out certain waves, sound waves and radio waves, and that will then create the sound that you desire. This is the fundamentals of all modern-day speech synthesis, a vocoder. And it's a term you'll hear again as we go through this talk. It's still present, just in, say, digital form now. And then comes the 1970s, and of course, in popular culture, the vocoder became popular as well. So the Korg vocoder became a musical instrument. Instead of having those horrible, strange-looking, scary keys, they made it look like a piano. And you can play a sound. So you would plug the microphone into this vocoder, you would say something, sing something into the microphone, and then you could use the keys, the piano keys, to manipulate and filter those sound waves. Early days of synthesizers. And then it came into the mainstream in popular culture. You may be familiar, in fact, with music that has vocoders used heavily in it. Daft Punk, if anyone's aware, of course, they're heavily using vocoders on all their voices. Equally, this song. I'll turn that off before we get copyright striked on the stream, but you get the point. It made its way into popular culture. So we've gone from this scary-looking scientific machine being built for research purposes and for military purposes to actually just now being used for a bit of fun. And they're sounding more natural and they're sounding a little bit more human. It's still robotic, but it's getting closer. Okay, enough history, enough science. We're going to talk about data, AI, and ML now. This is sort of what you came for. So the principles of any AI system are twofold. You need a model, and the model is your data and patterns that have been extrapolated from that data. And then you need training. Training is the most important part of any of this. Whilst the technology has got good for us to be able to quickly and accurately learn with computers, it's only as good as the data you give it. So if we're giving it really poor data, we're not going to get a very good output. Technological advancements have been on how we improve this training speed and the efficiency of training, because it's the most complex bit of, say, training any ML system. So, yeah, ML basically uses an algorithm to match data against some key points or metrics that you're going to score it with. So with that, you basically give it the training data, and then you have to, on a number of parameters, work out exactly how that all works. Let's take a very, very simple, crude example. I have a line 0 to 1, a percentage, if you will, 0 to 100, doesn't really matter. And if I say to it, okay, what is the average number on this line? Well, maths would say it's either 0 if there's no data, or null if there's not, or maybe it's halfway. If I plot a couple of points, let's say one in the middle, yes, the average is 0.5. If I start to plot a few more, then we get some different averages. And you can see here how those averages get clustered around a certain point. And so for any given piece of training data, when I give my model data and it's going to extrapolate certain bits of information, mathematical information about that data, it's going to go and try and find an average. And those averages are what we then use to fine-tune our model. When we're happy that that model has got a kind of a good understanding of what identifying a piece of data, we give it more data to reinforce that. If we give it a lot of junk data, slowly those averages start to shift and they're not where we want them to be. Tuning and training these models is a huge task. Thankfully, with tools like the Azure services, they've been pre-trained and pre-tuned. We don't really have to do that. We can bring our data, add it on top of their existing models, and then we can continue and benefit with some fairly powerful stuff. Now, okay, this is all quite scientific, but the techniques that Jesse Oral used for his augmenting myself in meetings task is not a million miles away from this. He recorded several clips of himself doing certain tasks. So he identified the tasks he needed. That was, I'm going to respond to, how was your evening, or hello. He's going to record several versions of that, and then he's going to decide in the moment on the best one he'd like to play. But you can imagine if we just took a computer and did that, actually this is effectively training an AI model. He's established his cases, he's developed some training data, and he's fed it over to that. He also said he only ended up using a small amount of the actual, the total number of clips he recorded. I think he recorded over 300 clips and ended up using very few of them because things like nodding and stuff is very repetitive, and you don't need to have a lot of variation of that, which again is this condensing of data that we see when we're training models anyway. We need to talk a little about learning and how ML models are actually trained and how they learn, because the idea that you could teach a computer something is a little bit weird, but it's a very simple logical process. We have a process called isolated learning. Isolated learning takes a data set, you give it a task, that's an algorithm you're going to apply to it, and out the other side you get data, an AI model, let's say, or an ML model, sorry. Those tasks differ. You'll have different algorithms for different cases. So if you're trying to identify, how frequent syllables are or certain sound properties, you would write an algorithm that knows how to identify that from an audio file, and then you'd continue. And you might do 3 or 4 tasks on any of this data, or thousands of tasks on any of this data. The problem is, the learning from each of these tasks is not fed to the next task. So we don't get any benefit of knowing, okay, I correctly identified these characteristics in my previous run, but now I've lost all that information. I have no way of knowing what happened previously. So recent development in ML training has been largely around this transfer learning approach. The T, for those that don't know, in ChatGPT stands for transfer. So we have a data set that's going to do the same learning, same process that it did before, but the output of those tasks then gets shared into the output of the following task, and the following task, and the following task, on a trillions of task scale for something like ChatGPT, where we then have a very comprehensive model at the end. This is effectively the only way you'd be able to do something like learning a language, because when you're learning as a child, you don't just forget everything you were told before. You're building up that knowledge. So transfer learning is the only way we can build and create a cumulative model at the end. And then you can start to take that model and pass that into another set of training and evolve this over time. These are the ChatGPT models, for example, that we've got currently in production are many, many years old, and they have many years of data. They're not starting from scratch training these things every single time a new iteration comes out. Okay, so that's your training data. This is most commonly used for transfer learning in cases like natural language processing, whereas isolated learning is possibly more for extrapolating statistics. So if you wanted to do some statistical analysis on data, you'd probably use isolated learning. Okay, now the moment you actually came for. Azure Custom Voice. So it is a speech synthesis service as a service. You can train your model. There is a Lite and a Pro plan available. The difference between these Lite and Pro plans is not what you'd think. They cost the same. They have the same feature set. But we'll have a look at what they, why you would use one over the other shortly. I was inspired to do this talk by Donovan Brown, who used to work for Microsoft. He's just recently retired. I saw a fantastic video a few years ago where he'd recorded a whole demo of the Azure Custom Voice service. And I was watching along going, yes, this is very interesting. And then at the end he says, and the voice you've been listening to for the last 5 minutes is completely automatically generated. And it sounded just like him. Now, when I was told, I could go back and hear a couple of little things. Like, okay, yeah, that sounds a little bit robotic. That's not quite so natural. But it was very, very impressive. And that was in 2021. With very minimal effort, he said he was able to create a natural-sounding voice. Now, he's one of these people who's been up on stage a lot, has a lot of material out there in the public domain where it would be quite easy to get together a high-quality set of recordings. A lot of conference talks, really good content, podcasts. Even if you wanted to sit there and record all of your Zoom meetings for a whole week, you'd probably build up a nice corpus of content. But if you don't have that, you can still go and you can train these models yourself. So you could sit there and record a big script, or you could record some specific utterances to generate this model and train this model. Here's how it works. So the idea of this speech service is we give it some text. It will analyze that text. It then applies that to a acoustic model, a neural acoustic model, and then to a vocoder. This is the same vocoder that we spoke about earlier, the horrible, scary machine that was in the 1930s is now just a piece of software on a computer in the cloud. And it understands all of these acoustic characteristics it needs to replicate. It understands that certain words have more energy to them, or even certain letters, certain vowels have more energy to them, and it can appropriately generate a sound wave that sounds like a voice, a human voice. And then that gets turned into audio output, of course. Now, the training is a little bit more complicated. So the base model that they've got running on Azure has about 3,000 hours per language of any of random voice data that they've accompanied with high-quality transcriptions. So they're able to tell their model when this sound wave is formed, or this, or this, or this, or this. That means this word, according to our transcript. They do that over many languages. They've got over 50 languages, and they've trained this extensively in the pre-trained models that we have. So they've gone and done all of that. They've used their huge compute power to go train these powerful models, and they've just made them available to us. They have some various different layers of teaching and filtering on these, but the core principle is we get a nice fine-tuned model at the end that we can feed our own data into to start to augment and create our own voices. So they ask for around 2 hours of speech. If you want to clone your voice and have something that sounds just like you need about 2 hours worth of content. As I say, if you've done a podcast before, you've probably got nearly a couple of hours of you speaking recorded somewhere, or a conference talk, or your meetings. That should be fine. The reality is you don't need 2 hours of speech. We'll see in a minute. You can actually train this on about 20 sentences of you speaking, and it still comes out fairly accurate. But the more data, the better. The better quality the recording, the better. I plumbed a podcast that I'd done into this model, and I do this podcast with my friend from Poland. He's great, one of my best friends, and it ended up making some kind of hybrid of both of our voices because it couldn't quite work it out. So I had a slightly Polish accent, and it's all about the data. If you've got audio that is just you, it's perfect. You can train it on just a recording. So then the process will go and it will learn and it will train that data. It will extrapolate all of the different things it needs from it to fine-tune the model. We're not training a new model here. We're just adding some additional data context on top. It then goes through a service called Fast Speech, which is an algorithm that the team at I think actually Google might have developed, but Microsoft are using it. There's a lot of sharing going on behind the scenes here. Whilst the whole ChatGPT thing is seeming like a kind of a winning battle for Microsoft right now, there's been so many years of research done by so many people across all these companies that, yeah, it's really quite incredible how much collaboration has actually gone into making these models what they are today. But yeah, the fast speech thing is purely there to improve the accuracy and the speed of the training, because these things are expensive and difficult to train. This is just a very efficient implementation, I think, of all the training stuff you need to analyze audio and turn that into something. Then you have a model at the end. So this output model is what we can then take forward in Azure and do lots of fancy fun things with. Okay, so I said there's a difference between Lite and Pro. Same feature set, same pricing. What gives? Why? Well, it's all about responsible use. Microsoft has made a really big deal about making sure that you can't misuse this. Someone couldn't go online, take my voice, and put that into their service and generate a clone to call up my bank and to try and take all my money or whatever. Responsible use is really important. So the Pro tier has the same feature set, except it allows you to actually use it in production. You need a pre-approval. You need to fill in a form. It's really annoying, actually, but it does make sense. You need to fill all this data in to say, here's what I'm going to use it for, here's why, here's how many people I'm going to show it to. Just for this presentation today, I had to give them a rough estimate of how many people might be in the room so they could know if it was being used appropriately or not. I've kind of joked here, but I don't want to see Troy Hunt on this stage in 4 years' time with a talk, has my voice been pwned, because loads of people's voices have been kind of brought into models, trained, and then used for nefarious purposes. So yeah, it's all about responsible use. Microsoft's, I think, taking a really good stance on this, and it's baked in at every single step, which you'll see when we start to take a look at the tech here. So yeah. Okay, so training a light model, they have two options. With the Pro tier, you can chuck thousands of hours of audio at it. So if you were building, say, a production telephony system, something like that, where you needed really high quality speech synthesis, you would want to give it thousands and thousands of hours of pre-recorded high quality studio audio. Whereas the light models actually give you a different way of doing this. So you can do about 20 to 50 utterances. When we say utterances here, we mean sentences. You can speak these directly into your computer mic on your laptop and get a still fairly good sounding result after about 1.5 hours. So the recording takes, in my experience, approximately 15 minutes, and the training itself takes about 60 to 90 minutes as well. You can then, if you have access to the Pro tier, deploy this model and use it elsewhere. I think we're going to have a little look at that one now. So a few things you need to be aware of when recording data yourself, to make it as easy as possible for you. You need a good microphone. Typically, the one in your laptop is probably good. Maybe if you've got a pair of headphones, that might also be fairly good. You need it to be direct. They say about 8 inches away from the microphone. I had some interesting results recording on my MacBook here, where they do a bunch of stuff in the background to try and do noise cancellation on the microphone, and also, if you're further away from the microphone, they'll boost up the audio to get it to a consistent level, but sometimes then it thinks it's too loud, and yeah, a lot of mess. But avoiding background noise is the key thing. You want a nice quiet space, quiet room. I live next to a really noisy road, so this was a challenge. Relax, speak naturally. I have a demo in a minute that will show what happens when you don't speak naturally, and just how that really impacts the end result. Try and do it all in one take. This is really good advice, because you need to keep your energy levels up and consistent. If you start training with data that you started on one day, and then you continue it the next day where you've got maybe a cold, or you've had a lot of meetings that day so you're a bit more tired, you end up with very different results, and you're going to have an inconsistent model. They give us some guidance, some quality metrics, as we're recording, to say whether or not it was good in their eyes. And then the more samples, the better, as we said before. Better quality data means a more accurate model, hopefully. So let's have a little look at how this works in practice. I'm going to make sure that's zoomed in enough for everyone. Can we all see? Hopefully. Good. So Microsoft has a fantastic set of tools, they call them studios, in their AI space, in their AI products. They have Speech Studio, they have Vision Studio, they have a Data Studio as well. These are self-service tools, portals you can go to work with any of their cognitive services products. So in this case today, we've gone to speech.microsoft.com, and I'm here and I can train up everything. I'm hoping these demos work well. I saw this morning a nice banner that said, there's a maintenance window today. Sometime it will be a 4 hours outage. If not, we've got recordings, but fingers crossed, right? So I go to Speech Studio, and I've got a wealth of capabilities here of things I can do. So I can do text-to-speech scenarios. I can do speech-to-text. So that's me speaking to my computer, understanding what I'm saying, or ripping audio out of, say, a video and saying, go transcribe this for me. These are what these services are for. Pronunciation assessment, if you want to check how good your language skills are, for example. Even the ability to create custom voice assistants. So I can say, create a NDC Oslo voice assistant. Hey, NDC Oslo, what talk's on next? And I can train all of that and sort of set up all the flows and what it needs to do. It's a very powerful tool. Today, we're going to be looking largely at the text-to-speech services and custom voice. So to get started, I'm going to click Custom Voice, and I can start to create a new project. So in this case, I choose what I want, and it sort of guides me. Do you want to do a light project where it's 20 to 50 utterances, and it's going to be of fair quality, but it may not be perfect? Or do you want to take this pro one that requires quite a lot more data, if you have the data? When I dive into the light one, I'll just give this a name. We'll call it NDC Oslo. It's important to select the gender. Now, this is a controversial one, perhaps, but it really does differ the underlying pre-trained model that is used. So I've tested this with a bunch of different configurations here, including with the language. It really matters. I'm from the UK. I speak UK English. If I put it through the US English model, yeah, it works fairly well. And it's a bit more fully featured, but it was not as accurate. It was far better for me to select this. For the gender thing, choose the thing that you best feel represents your voice, I think would be my advice. In this case, I'm choosing the male one, and I'm going to choose United Kingdom. This is where the whole consent thing comes in. I've got to agree to a ton of things just to even get started here, as you'll soon see. I've created my project. I can hit Get Started. I have to hit another disclaimer. I have to sign that, accept it. OK, everyone stay quiet for a sec. OK, damn. Fine. It thinks there's noise in the room. It's probably because the microphone that I'm using here is just on my laptop and it's picking up all the echoes. But it's going to do a check to make sure you're in an environment that it feels is suitable for recording and training your model. It's just a guidance here. I can hit Next and ignore it. And these are the things I showed you a minute ago, just about generating good quality audio. Then it brings me to this. I have a utterance in front of me that it would like me to record. So very British, we're going to start with this. We won't train a full 50 options, but I'll just show you a couple and see what the process is like. So I can hit the record button here. Would you like a cup of tea? OK, it was too loud, but it starts to give me some guidance. It says, yep, that was clear. Your pronunciation was good. Unfortunately, it was a little loud, but otherwise that was fine. Would you like a cup of coffee? Didn't recognize the wrong word there, but that's fine. It thought I said coffee instead of cup of, but it's able to identify when you've incorrectly said the sentence as well. So you can see how this would start to guide you through the process of training a model in a high-quality model. Of course, because this takes a little while, I've trained one already when it loads up. So I've completed all of these, all 50 utterances. Some of the sentences are a bit weird, like, your kids will be well looked after. It feels a bit wrong sitting there and recording these things, but the idea is they've given a broad range of sentences that allows the model, to identify all of the different possible characteristics that you might need, so it's got some samples. Examples, you can take a paid holiday. Where's my favorite one at the top? It's hard to deny that tomatoes are the ideal summer food. So here's what I recorded.
It's hard to deny that tomatoes are the ideal summer food.
So that's me speaking right now. And I've done this 50 times to train my model. At that point, I can hit this train model button, and away we go. I can then review my model. So this takes about an hour, as I said, to go away and train that model. But the output is this. It is a neural model based off of my utterances. Unfortunately, on the light plan, you can only play a set number of pre-allowed sentences. This is another one of those safeguards that they've put in place to make sure that I can't find randomly this talk online. Someone couldn't extrapolate each of those utterances I've done and train the model themselves. It's still got very limited use case. So in this case, I've trained a model. But here's how it sounds.
Congratulations. You have successfully created your synthetic voice with Custom Neural Voice Lite.
I mean, that's pretty impressive. It is undoubtedly my voice. It's not perfect, for sure. And there's some things that certainly sound a bit robotic, but actually it sounds like as if I'd recorded that and maybe wasn't that enthusiastic. But
with the full access, you can create an even more natural voice by bringing your own data recorded in professional studios using Custom Neural Voice Pro.
I think that's fantastic and really impressive. So if we look at how long it actually took me to record this, I sat in my hotel room yesterday evening and recorded all 50 utterances. The start time was 6:15 and the end time was 6:28. So all of 13 minutes to go and record that and create a model. I then did nothing. I went to the boat party, let it train, and came back, and it's working fantastically. Because I have access to the Pro plan, Microsoft very kindly enabled that for me. I was then able to deploy that model. And deploying it means I can use it in other contexts. I can use it with some of their other services and use it with a full scope of different scenarios. Let's put in here, for example, good morning, NDC Oslo.
Good morning, NDC Oslo.
Okay, still a little bit robotic, but we can tune that, and we'll see that in a second. That's how quick and easy it is to get a copy of my voice up and running. What happens if we don't do things so well? So that's natural. I've trained the same model, done the exact same process again, but this time without putting any passion or enthusiasm into anything I say. In fact, doing it completely monotone, just to demonstrate how that actually affects the output. I'll use the same example again, the tomatoes one.
It's hard to deny that
you get the gist. It's not very engaging. And you can imagine what this might actually do to the output model. Of course, I've got a pre-trained model here, and we'll just have a listen to how this sounds.
Congratulations. You have successfully created your synthetic voice with Custom Neural Voice Lite.
Okay, it's dull. So this really hopefully demonstrates the importance of putting a little bit of effort into training that model how you want it to come out the other side. If you want a nice, friendly tone, you're going to need to train it with a nice, friendly, enthusiastic tone. If you need it for a more corporate, more informative scenario, you're going to need to train it on a voice that sounds and matches that scenario as well. That's a really important thing. And I would hate for someone to spend 3,000 hours, for example, training a model with proper studio quality recording and then go, this sounds rubbish, it's really boring. You have to put a bit of effort into it. A bit of enthusiasm is very important. But yeah, very quickly able to get up and running with a custom voice. What about accents? Of course, the people in this room, nice diverse crowd from all over the world. You all speak English, but you all have an accent. I have an accent. How does it handle this? Well, so I was sitting at home recording some of these samples for this talk, and my girlfriend comes into the room, and she thought it was hilariously funny that I was having to say all these silly things to my computer. She's from France. Love her to bits. She's great. I said, okay, let's give you a try. Let's have a go. So she speaks, I'm going to call it Frenglish. French, English hybrid. It's like, it's English. She's got very, very good English skills, but it's with a French accent. A bit like some of you here, people from Norway. You'll be speaking English with a Norwegian accent. How do we train that? Does it handle it properly? Well, let's find out. So currently it does support a number of different languages and dialects. So in English, you have an English UK, an English US, Australia and Canadian dialects. So it will be able to differentiate those purely because the training data is available. I don't think within, say, Norwegian, for example, you'd be able to differentiate, is it Bokmål and the other one? I don't really understand Norwegian language, I'm sorry. But yeah, you wouldn't be able to I'd probably differentiate those just because the training data is not there, but at least for English we can. English, UK, US, Australia, Canada, France, German, Italian, Japanese, Korean, Chinese, Portuguese for Brazil, and Spanish for Mexico and for Spain, because there's obviously a difference there in dialect. They have models for these already. They don't have a model for Franglish or for Norwenglish. I don't know what we'd call it. Ponglish was the Polish English example that I spoke about earlier. They don't have these things. So what happens if we train it? We chose to train the same model, the exact same process that I'd taken with my girlfriend's voice in English, and we selected English UK because we thought that would be the best match. So we went and chose, an English UK model with a female voice, recorded the exact same scenarios. Just because you don't know my girlfriend, I will play you the same tomatoes example, just so you know what we're dealing with here.
It's hard to deny that tomatoes are the ideal summer food.
Okay, so some slight pronunciation differences compared to how I would say things, but it's a clear recording, and she was able to train this in, let's have a look, 30 minutes. So it took about twice as long. There were some issues with getting the model to actually recognize the words she was saying, because where in UK English I will say a the sound, it sounds more like a z sound in French or Franglish. It was a little bit interesting to get it to match, but we got there, and the model in the end sounds a little bit like this.
Congratulations! You have successfully created your synthetic voice with Custom Neural Voice Lite.
So, it is, without doubt, her voice is slightly different, though. It's actually made her a little bit more English. I'm not going to play you every sample, but it's removed some of the accented words because the model it was trained on was with UK English speakers and not someone with these slight accents. So just keep that in mind. Find the model that best fits your voice and your scenario if you're training it. It may not be perfect, and we can tweak it a little bit, as we'll see in a second. Also, just for a laugh, we got her to train the French one. Because she's a native French speaker, surely that would make sense and would be easy, right? It was not. It was far from easy. French is a very interesting language. Does anyone here speak French? We've got a few French speakers. I hope I don't offend you with any of this. I'm sorry. It's a complex language. I really struggle with it. There is nothing too similar to English. Its pronunciation is very important, and certain words that may be spelled very, very similarly or exactly the same sound subtly different but mean very different things, and you have to be quite careful. The model here is trained only on France French, the pre-built one from Microsoft, and I think it's quite formal and quite corporate. The French language itself has more formal language that you might use in a business setting, like English would, but maybe in a social setting or younger people would not use that sort of language. And so it's not best trained for those sorts of things. She went through and recorded, again, a lot of samples. Let's see how long that one took. About 25 minutes. Ironically, the one that took the longest, over 5 minutes, was a phrase that says, if we keep trying, eventually we will get there. And it just wouldn't pick up the words, the accent that she was saying, but hey. So, yeah, example.
La sortie annuelle du club aura lieu courant juin.
I don't know what that means, but it's something about an exit. And here's the output. So, again in French.
Félicitations. Vous avez créé votre voix de synthèse avec succès, avec la fonctionnalité voix neuronale personnalisée Lite.
It's absolutely her voice, but it lacks some of the personality and some of the things that she would say herself. It's far more corporate, it's far more clinical, let's say. Another thing about the French language is it's there's a lot of, let's say, non-verbal parts of their language. Now, things like expression, facial expression, is a really big part of expressing yourself in the French language. And you can't get that across in an AI model, can you? There's another word, my favorite word my girlfriend uses is which means I don't know. But I don't, again, know how you would train a model to say that. If we look at some more local examples, I believe in Sweden, your neighbors have, in northern Sweden, have a way of saying yes, which is like, it's the J-O, like a ya, but it's like an inhale. Again, I don't know how you would train an AI model to speak like that. So many dialects, so many differences, and of course, so little training data out there that we'd actually be able to make something that's necessarily got the personality you want it to. You'll have to put a bit of time and effort into making that work if that's something you want to do. Anyway, so we've talked about training the light model and shown you can, with very little effort, actually get up and running with 30 minutes of speaking at your computer in your hotel room, and it sounds kind of like me. Of course, if you want to invest a bit more time and effort, if you're doing this professionally, you would probably hire a studio, a voice actor perhaps, someone to spend all that time crafting a script. Of course, Microsoft actually offer a set of scripts, like pre-approved scripts, that they've ensured cover all of the different bases that you need. So they have everything from 300 to 2,000 utterances, and they're all on GitHub. So actually they're open source, people can contribute to them and add to them, and they're freely available. You can train with the Pro setup up to 15 different styles. And when I say styles, I mean things like whispering. You can train whispering. You can train excitement, anger, and we'll see that in a second. You can also, rather than just sitting there training against your computer, upload transcripts and MP3s, or even just the MP3, and it will transcribe it for you and go and work all that out. Of course, the more information you give it, the more accurate it is going to be, but that's not to say you have to go to the nth degree. Training takes a lot longer, whilst the training of the light model, because it's smaller, takes about 60 minutes to 90 minutes. This takes 24 hours. And you're paying for the training compute time, and it's not cheap. So again, if you were doing this in the real world, you would have to carefully consider whether this was worth doing. I threw a set of podcast episodes up at this, and it was about 12 hours worth of audio, and it maxed out the billing on my Azure account because it was getting very expensive. So just bear that in mind if you're thinking about training. I believe that the light model and the training for that is honestly good enough for most cases, unless you're doing something that requires really, really professional audio, perhaps like announcements on public transport or something that really needs to be crystal clear. If you're just doing it for your own internal uses, I think the light model is probably good enough. Okay, so what about accuracy? Now, this is a really challenging thing. As I said, there's variation between each language, each dialect, and also within businesses. If you're working in a business that has specific terminology, specific domain knowledge, and terms that have to be pronounced in a certain way, how do you get a generally trained model to actually know and understand these things? Well, that's kind of tough, but let's look at some ways of doing that. Within Speech Studio, we have the ability to create our own audio library as well of things. So I can go into this, and I can have a look at some of the ways we can manage pronunciation and control, say, a script. Now, this all comes from lexicon files. So we have to create a lexicon file that matches the culture that our model was trained on, so in this case, ENGB. We have to supply International Phonetic Alphabet phonemes to say how those words should actually be pronounced. You remember that diagram I showed you before where it says we give it some text, it goes through the neural voice, it goes through the vocoder, and then creates a response. Well, what that's doing under the hood is it's generating these phonemes, and then it's going to orate those phonemes with the vocoder. So if we want to be able to control exactly how some of these things are said, this is the way to do it. I mentioned that I work with Umbraco, a CMS. Now, there is a video online of someone saying, so how do you pronounce umbraco? umbraco. And there's 15 different responses. People don't know. Umbraco, 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 umbraco. Slightly different, but it matters. If you're a business and you are adamant that a certain word is pronounced a certain way, you need to be able to control it. So these phonemes are the best way to do that. I've been able here to specify a phoneme for umbraco using the International Phonetic Alphabet, and yeah, that's all I needed to do. Let's have a look at this in practice. So I've created a file here, and I've called it umbraco, and this is a US English voice called Guy, who's going to say the word umbraco.
Umbraco.
Umbraco. That's not how I would say it at all, but let's see what we can do. So I'm going to, down here, put another voice in. Let's do Jenny this time. So this is Jenny, who's, again, a US voice.
Umbraco.
Umbraco that time, so slightly different. If we put a UK English voice, for example. How does that... Oh, I need to select Libby, for example. And I will just turn that off because that's going to ruin my demo.
Umbraco.
Umbraco. Huge variation, right? So let's say I now actually want Libby to speak how I've set it to. So I've got my lexicon file. I can select that, and so Libby will now speak with the lexicon that I've provided for that voice.
Umbraco.
That's how I would say it. So there we go. I've been able to tweak the model with the output of the model and the vocoder just by providing a lexicon file. Now, wouldn't it be great if I could speak here as well? Like, my voice that I've spent all that time training and using, wouldn't it be great if I could tweak that? Well, of course we can do that. So I'll put my, my word in there. I will change my voice. I've got my cloned voice just up here, and I will remove the lexicon just for this demo and run it here.
Umbraco.
Umbraco. That's not how I speak at all. It's what the model thinks I would say, but I can apply my lexicon and...
Umbraco.
Umbraco. There we go. Fantastic. So that's just how we can start to tweak the output of these models. For the US ones, it's not supported in the UK yet, or other languages, unfortunately. You can start to dictate the speaking style. So I can say angry. It's lunchtime. We all get hangry sometimes, right?
It's lunchtime.
Or we can make it whisper or something. Whispering.
It's lunchtime.
That's not a whisper at all. But yeah, we can start to change the pace, the pitch, all kinds of things to really tune those voices to be exactly as you want. And then this carries through to every other Azure speech service that you want to use. So if you then wanted a text-to-speech scenario with one of these voices, with the lexicon you've provided, you can just select this file and away you go. It will generate the speech for you in that tone. Okay, let's talk about some practical use cases. Accessibility, I think, is probably the most important use case of any of this technology. You can imagine that somebody who has, say, a hearing or a speech disorder would find this sort of assistive technology, if it was applied in that capacity, really, really valuable. We're seeing Apple bring that to the iPhone natively. We'll see more and more apps, I'm sure, coming out with this over time. People who are deaf or deafblind and can't, say, easily talk to online services, or can't, it's more common that, like, your energy provider phones you up, or you have to talk to them on the phone, and that's not the most accessible thing you can do either. So these sorts of technologies could make lives easier for those people. Translation is a big one. There was a Google Glass demo a few years ago where they had two people speaking different languages to each other, but they were hearing a translated version of the other person and seeing a transcription as well. That's really valuable. Being able to communicate across barriers, not needing to learn all these other languages because we can apply ML models to them. Security is a fairly common one, and this has been used, I'd say, quite broadly across the industry in recent years, where you can call up your bank and they have an idea, a little model of your voice that you've trained over the phone to say, yep, that is definitely that person. Of course, it can be manipulated, as I said. CNN managed to do it only last week, but it is possible. Virtual assistants. We can create our own virtual assistants. We could create an NDC Oslo virtual assistant, like I said. And this one's quite close to my heart, a time capsule. The wonderful David Attenborough isn't going to be around forever, unfortunately, or Morgan Freeman, these iconic voices, where it would be lovely to be able to just can that and maybe responsibly use those voices to, for future generations. Or maybe a loved one, a family member. You could use this to capture some of those moments and still in the future be able to speak to a loved one even after they've gone. So there's some very interesting use cases there, and it's all accessible. It's all available through these Azure tools. Okay, $1 million question. How much does it cost? Literally $1 million question. It's $52 per compute hour. So if you're going to train that light model that takes about an hour and a half, expect to pay somewhere between $50 and $75 to train that. And then once you've deployed it, they call them an endpoint in Azure, it's $4 an hour to keep that endpoint running. It's expensive. So realistically, you're not going to be building this for a hobby, unfortunately. The cost of this will only come down over time, though, as compute gets cheaper, as these models become more widely deployed and accessible. So I hold out hope for the day where we could see that as, I don't know, $10 or something. How do you use these in your app? Well, the Azure Speech SDKs are fantastic, and they have them in basically every language. .NET, they have them in Python, they have them in Java, even C or C++, I think. So you could bake Objective-C too. So you could bake these into an iPhone app. You could bake these into your ASP.NET web application. You could bake these into a mobile app built with Maui. There's countless ways you can do it. And something I didn't quite get time to show you is when we go to a deployed model, it actually gives us a code sample for how to call it. So if I very quickly just go to my deployed model here, when it decides to load, below you can see this is the C# code you would need to go and do this speech-to-text scenario, text-to-speech scenario, sorry. Yeah, really easy to get up and running. Do you have to create a custom voice? Of course not. There's a load of pre-trained voices out there, which means you don't have to pay for all of that compute and training time. If you're happy with one of the out-of-the-box US English voices, great, go for it. There is a ton of voices in there and a ton of dialects too. They're not all perfect, but over 400 voices available. And of course, are there open source options? Yeah, hell yeah. We love open source. Whisper, which is another model that's come out of OpenAI, is there. You can deploy this on Azure's OpenAI service as well. Deep Speech and Mimic have also been around a little while longer. Free, open source things you can run locally if you wanted to have a play around with this sort of concept and technology. And with that, that's me. I hope you enjoyed this whistle-stop tour through cloning your voice with Azure Custom Neural Voice. I'll, of course, be around for the rest of the conference. I'm on Twitter, LinkedIn, Connect. Love to hear your feedback, and thanks again for listening. Hope you enjoyed the day.